Dr. Ningbo Wang from Chinese Academy of Science, from Aerospace Information Research Institute, will present talk about accuracy of real-time ionospheric maps. Please, Ningbo.
Okay, thank you very much for the introduction. So as we all know, within the IGS, we provide the rapid and final gene product. So in the provide the rapid and final gene product, in addition to the VTEC information, it also provides the uncertainty information there, or the RMS maps. But in case of the real time, within both the RTCM standards as well as the IGS-SR standards now, we only provide the real-time VTEC corrections. So in this presentation, I will show you how the uncertainty information of the provide the real-time VTEC information can be on the one hand calculated and on the other hand provided to the users in real time. And first I will give a short introduction to the IGS real-time ionospheric services. The one is that at current stage, we have 5 in total. The real-time analysis centers now can provide the real-time VTEC maps, especially since May of this year, NRCan from Canada also started to provide its real-time VTEC maps to the IGS. So by now we have 5 real-time analysis centers that provide the real-time VTEC maps to the IGS. And especially within the IGS, and previously we provided the real-time VTEC maps in both the RTCM standards as well as the IGS and the IGS format, but by now, all the real-time analysis centers are recommended or to only provide the IGS SSR standards, because in the coming or the next release of the RTCM standards, the global VTEC maps will be not supported by the RTCM standards. For the real-time combination ionospheric product, the UPC provides the first IGS combined real-time VTEC maps in 2019, and since 2022, there are 2 analysis centers from UPC and our real-time analysis center, CAS. We both provide the 2 independent combined real-time maps since 2022. So this table gives a summary of the current status of the real-time VTEC maps, provided on the one hand by each individual analysis real-time VTEC real-time analysis centers, and as I mentioned before, there are 2 ACs now also provide the real-time combined VTEC maps. You can see in the table, all the RTSs now provide the real-time VTEC maps only in or mainly using the IGS format. Yeah. In addition to the real-time VTEC corrections, we also archive the annex format in our own data center. So for the motivation of this study, because within in 2022, within the IGS real-time working group, we have how to say questionnaire distributed to the real-time GNSS community to request input on the real-time VTEC and on the real-time atmospheric corrections. So the first input we have got is that from the user side, they're requiring very higher real-time atmospheric corrections, and more than half of them prefer to use the real-time atmospheric corrections with the quality or accuracy but one tech unit. This is quite higher in my understanding, because when they perform the VTEC mapping, especially when you're performing the single layer or even the 2-layer assumptions, the mapping functions errors are quite larger. Then the second one is that in addition to the provide the VTEC or slanted informations, the uncertainty information are also highly required. You can see more than 80% users, they are quite interested in the uncertainty information associated with the provided VTEC informations. So in the IGS real-time working group recommendation in 2022, especially for the development of the IGS format. And for its phase 2, we plan to define a grid format to broadcast the RMS maps associated to the RTV VTech products. So after that, we have an internal real-time atmospheric task force. I would say the first task is for the real-time combination. I would say this now is almost done because now CAS and UPC two RTSs now can provide the real-time combined VTech maps. But another one is that I would say it is still ongoing. Before this task, we would like to make a real-time atmospheric RMS map design or the format design and provide those real-time RMS maps to the users. So in outside, how we can produce or calculate the uncertainty information of our provided real-time VTech maps. So in our case, we performed the how to say Bayesian interpretation, and after that we can derive this algorithm. You can see that for the calculation of the uncertainty information or the accuracy information of the atmospheric RMS information, we keep an imbalance for those regions with well data coverage, and because in other hand, we also need to provide the uncertainty information for those regions without any input data. So for the calculation of the RMS information, you can see in this algorithm, and first we need to calculate the uncertainty information of those regions where we have the input GNSS data. So these precision information are derived from the various covariance matrix, which are derived from our least square estimation in the real-time VTech corrections computation. Then we also considered, because for those derived precision information, normally it will be underestimate the uncertainty of the real accuracy, I would say. So we also consider, we also form how to say the caution fitting to compensate the biases, and as well as the how to say the standard deviations. Then we form these two parts together. So in my understanding is that we can calculate the RMS information for both the regions with the well input GNSS how to say data, and for those regions without any input GNSS data, we can also give some uncertainty indicators of the VTech information. So for the calculation of the VTech maps, you can see in the flowchart here on the left side, it shows how within CAS RTAC, the real-time VTech maps are computed now. And on the right side, it shows that following that new algorithms, how the real-time VTech maps are computed. So, and first we will calculate the uncertainty information at each individual grid point. Then for the broadcasting or transmission, those real-time VTech maps information to the users, we also perform in spherical harmonic fitting. Then we only broadcast those spherical harmonic the coefficients to the users. So for the calculation of the real-time VTech maps as well as the real-time RMS maps, we're now using around 180 IGS real-time stations. So we, as what we have done with our RTSC, we only focus on the Beidou 3, the GPS as well as the Galileo system. So in this figure, it shows, in the top, it shows the distribution of the input ionospheric information and each individual IPP. So I guess this is a time window of around 5 minutes. Then on the top right, it shows the distribution of the real-time VTech distribution. On the top side, as I mentioned before, for the computation of the real-time VTech map, we will and first calculate the uncertainty information and each individual grid point. So in our case, we give much more dense grid points for the low latitude and as well as the equatorial regions. But for the high latitude regions, we only give quite a small grids there. Then we perform in spherical harmonic fitting, then broadcast those spherical harmonic functions to the user side in real time. For the validation, so we and first aside from the positioning analysis, and first we analyze the performance of our provided real-time VTech maps in this in the ionospheric domain. I would say for the validation we're using about the 18 IGS stations which are not used in our RTGM computation. And for the validation, we also use we only use the GPS derived DS tag information. So at first we perform in Stanford-like plot here. So in this plot, you can find how well our provided RMS information can bound the real areas. So we select 4 IGS stations. 2 here. I only one. Sorry for that. Only one. I guess this is one station located in middle or high latitude, I guess. For our real-time RMS map, it was in the top left. And for comparison purposes, we also use compared with the final gene product from CAS from code, as well as the IGS combined final gene product. And at least you can find in this figure that there is some problems within the current IGS maps. I would say even those gene products are produced in the post-processing mode. Additionally, we also calculate the correlation between the RMS information as well as the real DS tag information. In the case the higher volume is got, it means the better of our provided RMS maps. Additionally, we also performed these real-time VTech maps as well as the real-time RMS maps in the single frequency PPP. I would say those information will accelerate the single frequency PPP, especially during the very first phase. So within the real-time community, we also have draft version for the distribution of the ionospheric messages assigned with the new message type 202. For the application, so in our case, our real-time VTech maps as well as the uncertainty information have been operationally run and China meteorological administrations for the ICAO space weather monitoring purposes. In the site, we also collaborate with several commercial companies to help to improve the single frequency positioning performance on the one hand for the smartphones, on the other hand for the smartwatches. So in summary, for the IGS real-time ionospheric services, I would say, at current stage, we have 2 real-time analysis centers can provide the real-time combined VTech maps. In addition, and CAS, we also provide the uncertainty information from outside associated with our provided real-time VTech maps. And we have provided the 2 mountain points here. I have shown here for those interested users who want to have a test to our real-time VTech maps as well as the real-time RMS maps. They can have free access of those data streams from both BKG as well as our own center. Thank you very much.